Now, when we perform partial fraction decomposition, we're going to need to work with proper rational expressions, where the degree on top is smaller than the degree on the bottom. Here, however, I have two examples of improper rational expressions, where the degree on top is the same as that on the bottom or bigger than that on the bottom, okay? And so how do we deal with those? Well, let's deal with those first. Basically, you're going to use either long division or synthetic division to rewrite them as the sum of a polynomial and a proper fraction. So you can essentially take an rational expression and turn it into a polynomial and a proper rational expression. Let me show you how that's done. We've done this before, but just as a quick refresher, what I'm going to do is, on this one, I'm going to long divide, right? So long division. And I'm going to take the bottom, x squared plus 7, and divide it into, oh, and I'm missing a term, aren't I? I really should have, remember when you long divide, you want to use, you want to fill in missing terms with a 0. So I should have x squared plus 0x plus 7. And on top I have x squared plus 0x minus 3. All right, and so if you recall the long division process, you take the big term, big degree term, divide by the big degree term. So it would be x squared over x squared equals 1. That 1 lines up, because it's a constant, lines up with the constant in the dividend. And then you multiply down. So 1 times 7 is 7. 1 times 0x is 0x. 1 times x squared is x squared. And if you recall, the process we used for long division at this point was to change the signs and draw the line. It was a saying I had that I've heard before. You change all the signs because you're going to subtract that to find the remainder. So you change the signs and draw the line, and then you combine your terms. So the x squares will drop off, the x's will drop off here, and negative 3 minus 7 is a negative 10. And so the resulting polynomial and proper rational expression are going to be 1, that's your polynomial, not much of a polynomial, it is a monomial though technically, minus 10 over the original divisor, which is x squared plus 7. And so we have now a polynomial, technically, and a proper fraction, proper rational expression, where the top has smaller degree than the bottom, okay? So that's one example. If we were doing a partial fraction decomposition, I would keep the 1 off to the side, and then I would just have to work with this proper fraction or proper rational expression part. Looking at the other example here, this is one where I might use synthetic division. And if you'll remember with synthetic division, in order to use synthetic division, the denominator must be in the form x minus a constant, okay? It has to be in that form. You can't have a quadratic on the bottom. Quadratic on the bottom requires long division. You really can't even have something like, you know, I don't know, 2x minus c or 3x. If you have another coefficient in there, synthetic division won't work also. All right, so in this case we can because of the 6. Of course, this is really a negative 6. And so in synthetic division, you use what we call the 0 of the denominator, which is negative 6. And then we use the coefficients from the numerator, 1, 3, negative 7. And draw our line, bring down the 1, and then multiply and diagonal. Negative 6 times 1 is negative 6. Add down, you get negative 3. Negative 6 times negative 3 is 18. Add down, and you get 11. All right, 11 being our remainder. 1 is the x term. Negative 3 is the constant. So this fraction becomes 1x minus 3 plus the remainder 11 over the original denominator. Okay, and again, we have a polynomial plus a proper rational expression. And if, again, we were doing a partial fraction decomposition, I would keep the polynomial and then just work with the proper rational expression at that point, okay? This one can't be broken down because the denominator is already linear and is irreducible. We'd be okay with that. Basically, the idea is to take any rational expression and break it down into a proper rational expression in this form, where you have as small of a polynomial on top as you can possibly have over one of the factors on the bottom. Okay, so we'll get into those details in the next couple videos.